All right, so for the second video in the series, I want to go into the actual system of how we're storing the memory. It's a very simple, small class. There's only like 25 lines of code in it, so it's not a big deal. And we will be coming back to it again later, but it's very straightforward. All it's doing is storing the information and bringing it back to us as we need it. Plus, we need a central repository for that. Now, I do want to call out that when I'm sitting in, when I enter a new scene or any existing scene, I usually like to take all of my managers, all of my systems, the things that define the core structure of what the scene is about, and put that right at the top. So systems and managers right there at the top. The bots in this case, because they are centrally controlled, and that's how they'll operate in this game, or in this toy, I'm going to put that right up near the top. But these cubes, the main camera, the lights, that stuff that goes on after the fact, it has less controls over exactly how it gets worked with, because these systems up at the top that are working with those. All right, let's dive into the code. So there is a cube system here. The cube system has no fields. What's going on inside of it? So in this mono behavior, we have a singleton instance to it. Now, I myself have said in the past that singletons are terrible practice. You shouldn't use them. It makes things untestable. You're putting logic into a non-instance state, and that can be kind of scary. Or not just the logic, but data storage. And when you start doing that and you have multiple positions that can start interacting with that without a control between how it gets to it, there's more chances for bugs. But quite frankly, singletons are pretty straightforward, and you can basically duplicate the exact same thing by following non-static field references, where you just get the access to it. You can generate all the same bugs without it. And you can still make singletons testable, and I've got some other videos that show how to generally bring them in line with standards and reasons why we wouldn't use them in the first place. So in my opinion, use singletons, and you can set them from the constructor, because domain reloading doesn't care about this. Well, actually, domain reloading does clear out that stuff, the singleton instances, singleton memory. But the construction of an object, yeah, you create the object, and as soon as it gets instructed, you set the instance. But when the scene is loading and it's serializing, it's not messing with any of this stuff, with any of the static references. So you can set that in the constructor, and it's fine. All right, now I have a dictionary of cubes. This is each cube that we have stored in here. And right now I'm just using a cube system. I might use a chunking system or some other system later on as we extend this, but I don't need to think about this yet. I'm just going to build the easiest solution to begin with and enhance it as we find it's necessary or important. Okay, so that is, its key is vector3 int, and its value is going to be the cube. Now, you'll notice that this is private. So one of the reasons that this is private is because this is the data of this class. I could have very well just made this dictionary publicly available, so anything could just say cubesystem.instance.cubes and add a cube to it, and I could have skipped this function at all. I could have skipped the hasPosition function or the contains key function. Has position function, and just use the contains key. But at that point, I effectively am requiring other classes to understand and manipulate the data of this class, unaware of the rest of the logic of this class. Or the rest of the logic of this class would be unaware of what other systems are making changes to it. And that is just flat out a bad practice. That is an area where you're going to introduce all sorts of new bugs, because your data gets changed from multiple points and you don't have a control system to define where that comes from and strictly define its use cases. That's what the functions are doing. So that's an important one right there. All right, during the awake function, we are going to do one intelligent check here, and that is to take a look through every object in the scene that is a cube and add it to our existing cubes. And that's how we can take our existing, let's just stop that, our existing cube right at the beginning, and make that the starting point of the game. And of course, I already mentioned that we have has position, which overrides the contains key, and we have add cube, which adds the cube. Now, I do want to call out that this add cube function is not doing a check for duplication. It's not doing a contains key check on the position. It is normal practice for any professional developer, any senior level developer, that when you're starting to work with a dictionary and adding stuff, that you always put in protections to make sure that you don't accidentally add something with the same key. However, I know this code. I am designing it with the intent that whenever I'm working with a dictionary, anything working with the dictionary has its own set of responsibilities to make sure that that data is safe. Now, there is another logical thing about this, that the dictionary is not exposed, so no one outside of this class is actually aware of it, technically speaking. But this is all in the same project. The only reason I put private here is just to make the developer not default to this set of operations. I want them thinking differently about how they use the functions, not the collection. Now, if this was for an API, then by all means, I mean, that's going to be for developers that have no reason to be inside of this code base and understand any of the nature of what they're working with. So all of these functions, yeah, you need to do your checks to make sure that you're not just going to trigger an exception, that you cleanly exit out or potentially have that path of it, that you've at least considered it and designed on purpose how you exit out in case of an error. All right, now that is it. That is the storage of this information. Now, I don't have anything that actually gets the cube because right now I don't need it. No reason to create anything extra. That's going to be in the next video. All right, I will talk to you later.